Let's take a look at the Fibonacci sequence. The way in which subsequent numbers are generated is by adding the two preceding numbers. So the next one would be 5 plus 8, which is 13, after that is 21, and so on and so forth. The formula can also be rewritten in a matrix form as such, which in turn is equal to this. And if we keep repeating this process until we end up with the first numbers of the sequence, we get this simple formula. With the help of the magic world of math, we can get this equation, which is the closed form of the Fibonacci sequence. It makes it way simpler to easily calculate any specific number of the sequence. Enough with the math formulas, let's go back to the sequence. These numbers may seem simple, but they hold a world of beauty and fascination. Another way to visualize them is with the Fibonacci tiling, which are squares with side lengths equal to the numbers of the sequence. If we mark points on the opposite corners of each of the squares, by connecting these points with circular arcs, this fascinating spiral arises which looks like a seashell, and it is called the Fibonacci spiral, and it approximates the golden spiral. Speaking of the golden spiral, the golden ratio plays a significant role here. It can be calculated by dividing a Fibonacci number by its previous number in the sequence. As we go further into the sequence, the ratios between successive Fibonacci numbers converge toward the golden ratio. It is approximately equal to 1.618 and gets often denoted by the Greek letter phi. It's a mathematical constant that has fascinated mathematicians, artists, and scientists for centuries. Another way to visualize the golden ratio is by drawing a line and finding the exact point where alpha plus b is to alpha as alpha is to b, or to put it in a mathematical way, the point that verifies this formula. This ratio is also equal to phi. If we do some math magic again, we end up at this quadratic equation, which by solving we get the closed form for the golden ratio, and more specifically, phi is equal to 1 plus square root of 5, divided by 2, which is equal to 1.618 as we mentioned before. What makes the golden ratio so intriguing is its appearance in various forms throughout the natural world and in human creations. From ancient architecture like the Parthenon in Greece to the mesmerizing artwork of Leonardo da Vinci's Vitruvian Man, the golden ratio has been utilized to create aesthetically pleasing compositions that captivate our senses. Nature itself seems to be governed by this mathematical principle. The spirals in sunflowers, seashells, pine cones, and even galaxies follow the proportions of the golden ratio. It's as if mathematics has woven itself into the very fabric of our universe. Beyond nature and art, Fibonacci numbers and the golden ratio find applications in various fields. They are utilized in financial modeling, computer algorithms, and even in creating visually appealing designs in user interfaces. Why is the Fibonacci sequence so important in nature? The sad truth is it isn't. If you embark on a study of nature as a student of biology, or chemistry, or physics, you will quickly observe that the Fibonacci sequence very consistently fails to make an appearance. It doesn't show up in the study of the quantum theory of the hydrogen atom, it doesn't show up in the study of Einstein's field equation or Maxwell's equations, it doesn't show up in the structure of the living cell, or weather systems, or the periodic table, or the DNA, or tectonic plates, or snowflakes. So although the math and the spirals are beautiful and brilliant, the Fibonacci sequence and the golden ratio are not so important. The lesson to be learned is even though something may seem so fascinating, it might actually be unimportant. And on that ending note, thank you everyone for watching.